Hello and welcome. I am Dr. Pauline Fu. In this video, I will talk about discrete probability distribution. Learning objectives. Distinguish between discrete and continuous random variable. Identify discrete probability distribution. Graph discrete probability distribution. Compute and interpret the mean of a discrete random variable. Interpret the mean of a discrete random variables as an expected value. Compute the standard deviation of a discrete random variable. So first concept, what is a random variable? A random variable is a numerical measure of the outcome from a probability experiment. So its value is determined by chance. Random variables are denoted using letters such as X. If I throw in a coin, the outcome either head or tail. So in this case, either head or tail is the random variable because the outcome is determined by chance. We don't know it will be a head or tail. Next concept, discrete random variable has either finite or countable number of values. Okay. It is either finite or countable. And we can express the discrete random variable on this line. So each dot is the possible value of a discrete random variable. These numbers is finite or can be counted. On another hand, a continuous random variable has infinitely many values. So if this is a random variable X, it could be any value starting from 0 until infinity. Okay, could be 0.4, 0.96, 1.5, 2.75, etc. It has infinitely many numbers, so we use this line. There is no point, not like the discrete, we have a point because it has a finite or countable value for discrete random variable. Continuous random variable has infinitely many values. Now let's look at an example to distinguish between discrete random variable and continuous random variable. Determine whether the following random variables are discrete or continuous. State possible values for the random variable. Question A, the number of light bulbs that burn out in a room of 10 light bulbs in the next year. Okay. So this is discrete because it has a finite number, or you can count the number of light bulbs that burned out. Maybe 0 light bulb burned out. Maybe 1 light bulb burned out. Maybe all 10 light bulbs burn out. So this is the discrete. Question B. The number of leaves on a randomly selected oak tree. Okay. This one is also discrete because it is an oak tree. It is a tree. Although a tree has many leaves, but you can count. There's a finite number. You can count, okay? No matter how big the tree is, you can count how many leaves. So it is discrete. Question C. The length of time between calls to 911. Okay, and this is the continuous discrete variable because it could be any value that longer than 1 second or 1 minute. Okay. So next, we are going to identify discrete probability distributions, and we are going to use this example. Okay. This table shows the probability distribution for a random variable x. X is a random variable. And this random variable represents number of movies streamed on Netflix each month. Each month you have some movies streamed on Netflix. And the number of movies streamed on Netflix could be 0, could be 1, could be 2, 3, 4, 5, etc. And based on the data, we calculated the probability of 0 movies streamed on Netflix is 0.06, and the probability of 1 movie streamed on Netflix is 0.58, etc. So the last one, the probability of 5 movies streamed on Netflix each month is 0.01. And we call this table is a discrete probability distribution table. Okay. So what is a probability distribution? Okay. It is the possible value of the random variable x. Those are the possible value of random variable x and their corresponding probabilities. Okay. There are some rules for discrete probability distribution. Rule number 1, all the probability are together equal to 1. Okay. So if you add all these numbers together, it must be equal to 1. Okay. The second one, the probability must be between 0 and 1. You see all these numbers between 0 and 1. Oops, too dark. Okay. So that is the rules for discrete probability distribution. Now let's look at another example. Is this probability distribution? Is this table represent a probability distribution table? Okay. The answer is no, because if you add all these values together, you get 0.97. Okay. To satisfy probability distribution table, all the number for probability added together must be equal to 1. Okay. So this is not probability distribution because all the probability added together is not equal to 1. So let's check this table. Is this table a probability distribution? This table a probability distribution? The answer is no, because you have a negative probability. The probability will never be a negative number. Okay. this one here. Is this table a probability distribution? Let's check. Number one, if you add all the probability, add all these numbers together, do you get 1? The answer is yes. You add all the probability, it is equal to 1. Second condition, all the probability between 0 and 1. The second condition also match. So this is a discrete probability distribution table. So far we talked about discrete probability distribution table. Now let's talk about the graph discrete probability distribution. Okay. And the question asks you to draw a probability histogram of the probability distribution of this one here. This represents the number of movies streamed on Netflix each month. To draw the histogram, you just use Excel, select data range first, and then you go to Insert, Chart. If you are using Office 365, you should have a histogram. If not, you can go to Data Analysis, and then you can find, I'll show you here. So Data, and then Data Analysis. And you'll have histogram, okay? So that is the graph. Okay. Now we'll talk about the mean of a discrete random variable. It is based on this formula. We use mu x represent the mean of a discrete random variable. How do you calculate? You use random variable times the probability of random variable, and then add them together. Okay. X represent the value of random variable. Px represent the probability of x. Okay. So now let's do the calculation for the mean of a discrete random variable given this table here. What is the mean of a discrete random variable? This table represents the number of DVDs a person rents from a video store during a single visit. When you visit a video store, you may rent 0 DVDs, or you may rent 1, etc. You may rent 5. And Px represents the probability of the number of DVDs you rent. So how do you calculate the mean of a discrete random variable? You use this formula. So first, write down the formula. And what does this formula say? It is said, use x, so this is x, times px, 0.06 is px, so you get x times px. Do next x, next is 1 times the probability of 1, 0.58. So 1 times 0.58. Keep on going. Next one is 2. The probability of 2, 0.22. So 2 times 0.22. Until the last one, number 5, the probability of 5, 0.01. So 5 times 0.01. And mathematically, this sigma means add all together. Add all the product together. That means sigma. Okay, and the result is 1.49. How do you interpret this 1.49? How do you interpret? So the average number of DVDs is 1.49. Okay. This example represents number of DVDs rented by 100 randomly selected customers on a single visit. So all the data here is 100. Compute the mean number of DVDs rented. So this one directly gives you the raw data. Okay. So how do you do that? The mean number of DVDs. So there are total 100 number. And the mean, we use X bar. You add all these numbers together, 1 plus 1 plus 1 plus 1 until plus the last one, the second last one plus 1 plus 0. Add all these 100 numbers and divided by 100, you get 1.49. The same result as we got from this probability distribution table. This is because this table is based on the raw data here, the original data. Okay. So this one gives you a graphical representation. X represent trial, number of trials, and Y represents the mean. As the number of trials of experiment increases, the mean number of rentals approached to the mean of the probability distribution. Okay. And this demonstrates the large number, the law of large numbers. Okay. Because the mean of the random variable represents what we expect to happen in the long run, it is also called expected value using EX. Again, another example, computing the expected value of a discrete random variable. This is the context. A term life insurance policy will pay a beneficiary a certain sum of money upon the death of the policy holder. These policies have premiums that must be paid annually. Suppose a life insurance company sells a $250,000 one-year term life insurance policy to a 49-year-old female for $530. According to National Vital Statistics Report, the probability the female will survive the year is 0.99791. Compute the expected value of this policy to the insurance company. So here we need to identify what is the random variable X. Okay. So the random variable X is the money you paid to buy the insurance. Okay, so when that is 550 survives, if you survive. Okay? And if you survive, the probability based on the National Vital Statistic, it is 0.99791. But if in case you die, the insurance will give you $250,000 but you already paid 530 up front. So you are going to get this amount, okay, 249,470. And what is the chance of this? You use 1 minus 0.99791, and you get 0.00209. And then the expected value of x equal to, based on the formula, x times px, x times px, and add them all, sigma. So x is 530 times px, 0.9979, you get this one. And then plus next x, negative 249,470 times the probability. And you get the result, 7.5, okay, $7.50. So that is the expected value of this policy to the insurance company. So far we talked about the mean of our discrete random variable. Next, we'll compute the standard deviation of our discrete random variable. We use sigma x represent the standard deviation of our discrete random variable. And this is the formula. You use random variable x minus the mean square times probability of x. And then add them all, sigma. Finally, you have to take the square root. Okay. Another way to calculate is using this formula. X squared times px, add them all, divide, then subtract the mean square. Take the square root of the result. Okay. X represents random variable. Mu x represents the mean of the random variable. Px is the probability of x. So this table is about number of DVDs a person rent. The question asks you compute the variance and the standard deviation. Okay. Remember, we already calculated the mean. The mean is 1.49. Next, we are going to calculate variance and the standard deviation. Okay. So what is variance? So sigma x is a standard deviation. Sigma x is a standard deviation. And what is variance? So variance is sigma x squared. That is the variance. You take a square of the standard deviation, you get variance. Okay. So this equal to, actually you take away the square root, you get the variance. It is sigma. Okay. X minus mu x square, then multiply px. So this sigma refer to this one here. Okay. And you get variance. So this is variance. Variance. Okay. Once you have variance, you take square root of the variance, you get standard deviation. Okay. So let's calculate variance for this question here. Okay. So this is original mu. The original data give you the x. original data, you have X, and you have PX. Those coming from original data here, okay, X and PX. We already calculated the mu. Mu is 1.49. Because it is a mu, mean it is the same for every variable value, okay? And now you use this X minus mu X. So 0 minus 1.49, you get negative 1.49. 1 minus 1.49, you get negative 0.49, etc. The last one, 5 minus 1.49, you get 3.51. So you calculated X minus mu. Why you need that? Because the formula needs that item. See, this is X minus mu. And then you have to square it. Why square it? The formula said you need to square it. Okay, so you square negative 1.49, you get 2.22. Square negative 0.49, you get 0.24. Last one, you square 3.51, you get 12.3132. Okay, and once you square it, and you have to times px. Why times px? Because the formula said you need to use this x minus mu x squared multiply px. So you need this px value. And then you do multiplication here. Okay, so that means you use 2.2201 times 0.06, and you get 0.1332. And you use 0.2401 times 0.58, you get 0.139, etc. You keep on going until the last one, 12.32 times 0.01, you get 0.123. Okay. So that is the, and you have to, finally, you have to add all these values together. Add all these values together, you get 0.898699. See this sigma? Sigma means add them together. Okay, so the variance is 0.8699. And how do you, this is the variance. Once you get variance, you take square root of the variance. Okay, take the square root of variance. Take the square root, you get standard deviation. So standard deviation is 0.9327. So that's all for this video. In summary, what we did in this video, we actually did 3 things. One, we introduced discrete probability distribution must satisfy 2 conditions. One is all the probability between 0 and 1. The second, add all the probability together equal to 1. So that is the first item, discrete probability distribution table. And the second, we calculate the mean of a discrete variable, okay? Mean of a discrete random variable. And the third, we calculated the standard deviation of a discrete random variable, okay? So that's all for this video. Thanks for watching. Hope you learned something. I look forward to see you in next lecture.